Who are you? And are you actually who you claim to be? That's the basic question every authentication system needs to answer. Welcome to another episode of Firecast, in which we will talk about authentication and how to make implementing Sign In with Apple easier by using Firebase. Knowing who your users are can be more or less important to your app. For a camera app that stores photos in your local camera roll, probably not that important. Storing notes in a note-taking app that your users want to use on their other devices, definitely useful to have some sort of identification so they can sign in on their other devices to access their data. Sharing data between multiple users with various levels of access, you're going to need a solid authentication and authorization system for sure. Implementing authentication and authorization has always been a challenging task, and it's easy to make mistakes. Not only that, but it consumes time that you'd probably rather spend on implementing the key functionality of your app. Thankfully, Firebase provides a powerful and easy-to-use authentication solution that is integrated with many of Firebase's other products, such as the real-time database, Cloud Firestore, Cloud Functions, and others. Firebase Authentication is a drop-in solution that you can easily integrate with your iOS, Android, and web applications. It supports a number of ways for users to sign in to your app, such as password authentication, Facebook login, Google sign-in, Sign In with Apple, and more. Thanks to Firebase's support for Sign In with Apple, it is now easier than ever to build iOS applications that allow their users to sign in with a simple biometric check, all without having to care about passwords. And thanks to mandatory two-factor authentication, this is super secure as well. Today, I want to show you 2 ways to implement Sign In with Apple using Firebase. The first one is super quick and will get you started in literally less than 5 minutes. The second one is a little bit more complicated, but provides a lot more flexibility. At the end of this video, I'm going to show you a couple of use cases that you can implement once your user has signed in. So make sure to stick around till the end. FirebaseUI is an open source library that is available on iOS, Android, and the web. It is built by the Firebase team and addresses many common use cases that developers encounter. For example, it simplifies Firebase authentication by providing pre-built UIs for all authentication providers that are supported by Firebase Authentication. Thanks to Firebase UI, you can implement Sign In with Apple in just a few steps. So let's have a look. To get us started, I've already created a simple UIKit application that just displays a simple button which says Login. I then created a Firebase project, registered my iOS app with it, downloaded the Google Services info.plist configuration file, dragged it into my Xcode project, installed the Firebase SDK using CocoaPods, and called Firebase app.configure in my application delegate. No idea what I'm talking about? Watch this setup video first, and then come back. So when using Firebase UI, implementing Sign In with Apple becomes a 3-step process. Step 1. To use Sign In with Apple in your Firebase project, you'll first need to activate it. In the Firebase console for your project, enable Sign In with Apple in the Authentication section. Back in Xcode, add the Sign In with Apple capability on the Capabilities page in the target settings. And finally, add the Firebase Authentication SDK to your app by installing the Firebase UI pod. Step 2. In our app, we've got this nice little button here on our UI. We want to trigger the login process when the user taps this button. To do that, let's first create an action handler by right-clicking on the button and dragging to our view controller. Next, we need to instantiate Firebase UI's default authentication UI. Firebase UI supports multiple sign-in providers at the same time, but we just want to use Sign In with Apple for now. So let's create an array that contains only this one provider. We set the delegate to self, which means we'll need to implement the did sign in with auth data result method, which we'll do in a minute. Finally, we retrieve the auth view controller and present it modally. Step 3. Now let's implement the didSigninWithAuthData result callback. This callback has two parameters, one with the result of the authentication process and another one in case something went wrong. We can extract the signed-in user from the auth data result and then print their user ID and other data, such as the display name or their email address, in case they decided to share this with our app. You're now ready to run the application and sign in with Apple. Well, this wasn't too bad after all. And the great thing about Firebase UI is that it makes it so easy to support additional authentication mechanisms. Adding a new authentication method is a matter of just a few minutes and requires almost no coding, as Firebase UI does all the heavy lifting for you. Check out the documentation at this URL to learn more. So at the beginning of this video, I promised you to show you another way to implement Sign-in with Apple, which begs the question, why would you even do this? Especially since Firebase UI makes our lives so much easier already. Well, firstly, implementing this yourself gives you slightly more flexibility. Also, it's always good to understand how things work under the hood. Plus, it's a lot of fun, so let's dive in. So just like for the first example, I've created a single view application and connected it to the same Firebase project. Sign-in with Apple is already enabled for the Firebase project, so we can go straight to Xcode and add the Sign-in with Apple capability to our app. And finally, install the Firebase Authentication SDK by adding the Firebase Auth pod to the pod file and running pod install. While this is running in the background, we can continue and build a sign-in screen with the Sign-in with Apple button on it. To do so, I'm going to import the Authentication Services module and then instantiate AES Authorization Apple ID button as soon as the view appears. When the user taps on the Login button, we want to display a sign-in screen with the Sign-in with Apple button on it. So let me quickly create an action handler for this and a method to start the sign-in process. Then, let's connect the handler method to the button. With this basic plumbing in place, we can now create an authorization request. Let's first create a helper method to keep our code nice and tidy. In the method, we first ask the Apple ID authorization provider to create a new request for us. By specifying the email and full name scopes, we tell the API that we're interested in these pieces of information about the user. I'd like to point out that Apple encourages developers to limit the scopes as much as possible in the interest of the user's privacy. So keep that in mind when implementing this in your app. In the next step, we will compute a random string that helps us to prevent replay attacks. This random string is also known as a nonce, which is short for number used once. The Firebase documentation contains an implementation of a secure nonce generator, which we're going to use. Now, let's generate the nonce, compute the hash and store it in the authentication request, and finally, store the raw nonce in a local variable so we can retrieve it later. To better understand why the nonce helps prevent replay attacks, let's have a look at this flow diagram. First, in your app, you create an AES Authorization Apple ID request, which includes the scopes you're requesting, as well as the hashed nonce. The app holds on to the raw nonce in memory so it can send it to Firebase in a later step. This ensures an attacker can't get hold of it. Next, iOS will display the sign-in dialog and guide the user through the login process. When returning from the sign-in flow, Apple will return an AES Authorization Apple ID credential, which contains an ID token. This ID token represents the user that has just signed in via Apple's authentication dialog. The token contains an opaque user ID that Apple uses to identify the user, as well as the user's email address and full name according to the scopes you requested earlier. The ID token also contains the hashed nonce we sent in the first step. As the ID token is a cryptographically signed JOT, we can verify its integrity. And this actually happens in the next step. So in step 3, we create an OAuth credential using the ID token and send it over to Firebase along with the original unhashed nonce. Firebase will then verify the ID token as well as the nonce. To verify the nonce, Firebase hashes the raw nonce using the same hashing algorithm we used in the first step, and then compares the result with the hashed nonce in the ID token. If both values match, all is well, and we can be sure that we weren't victim of a replay attack. This works because we use the nonce just once and create a new nonce for every new sign-in process we start. So even if an attacker was able to capture the original request, it would be impossible for them to unhash the nonce, as we're using SHA-256, which is a one-way function that is easy to compute but hard to invert. Finally, Firebase will return an auth result which contains the signed-in Firebase user. Now that we've got the request, we can instantiate the authorization controller, set the delegate and presentation context provider to self, and then kick off the login process. Before we can run the app, we need to stub out the delegate methods. It's a good practice to use extensions to manage delegate implementations, so let's introduce 2 extensions here. One for handling the authentication callbacks, and the other one for handling the presentation context. This lets us specify which window should host the authorization controller. At this point, iOS will display the Sign in with Apple UI and walk the user through the process of signing in. It will show the privacy information screen, ask them whether they're happy to share their email address, or would rather use an anonymous one that Apple manages for them, and then call back into your code. So far, none of the code we've written is specific to Firebase. In fact, it should be very similar to Apple's sample code. But now, let's switch it up a gear and connect to Firebase. To do so, we'll need to turn the ID token we received into a Firebase credential, and then ask Firebase Authentication to sign in with this credential. So here in the did complete with authorization callback, we first extract the authorization credential provided by Apple. Next, we perform a couple of sanity checks. For example, we make sure that the current nonce is set, because if it's not, we're in an undefined state. We then retrieve the ID token and convert it into a string. Using the nonce and the ID token, we can now ask the OAuth provider to mint a credential representing the user that has just signed in. In the next step, we will use this credential to sign in to Firebase. Firebase will verify the credential, and if it is valid, will sign in the user. In case this is a new user, Firebase will create a new user account using the information provided in the ID token. In the callback, we can now retrieve the Firebase user from the auth result and display the user's information. Oh, and in case you were wondering, Firebase will persist the user's credentials in the iOS keychain and retrieve them at application startup. So if you want to check if the user has already signed in, you can use this code snippet and update your UI accordingly. And this concludes our brief introduction to implementing Sign in with Apple using Firebase. So, where do we go from here? Well, first of all, I would like to encourage you to implement Sign in with Apple on all other platforms your app is available on. This will ensure your users can use the same credentials on all platforms. This is really important, as most users will use your app on multiple platforms such as their phone, their desktop computer, and maybe a tablet. The Firebase documentation contains guides for implementing Sign in with Apple on the web and on Android, so go and check them out. You should also start looking into any other authentication providers that your users may expect in your app, such as Google Sign-in or Facebook Login. One authentication provider that I find really useful is anonymous authentication. This lets you create and use a temporary and anonymous account to authenticate with Firebase. This allows users who haven't yet signed up to your application to access data provided by Firebase security rules. And once your users decide to sign up with your app, It's easy to link their anonymous account to an identity provider such as Sign with Apple and turn them into a full account so they can sign in from their other devices as well. Finally, and most importantly, start implementing functionality using some of Firebase's backend services. For example, you could use Cloud Functions to send new users a welcome message, or store data in Firebase real-time database or Cloud Firestore. Firebase provides security rules to help you secure your application and make sure users can only access data and functions they're allowed to. Check out Todd's and Rachel's video about setting up and testing security rules to learn more. And in a sad event that your users would like to stop using your app altogether and delete their user account, there is the Delete User Data Firebase extension, which provides an easy way to clean up after them. There is much more than we can cover in this video, so go ahead and check out the Firebase product overview at this URL. And there you have it. That was an overview of how to implement Sign with Apple using Firebase Authentication. If you found this video helpful, don't forget to hit the thumbs up button, and be sure to tell me which authentication provider you want to learn about next in the comments below, or at Peter Friese on Twitter. See you next time in another episode of Firecasts.